Going on, guys? Let's look at this problem right here. This question is asking a certain radioactive material decays at a rate proportional to the amount present at times t is equal to 0. There are 50 milligrams. After 2 years, 20% has decayed. The first question is asking find an equation to model this decay. Now let's look at the given information. They have said that when t is equal to 0, 50 milligram remaining. So when at p of 0, we have 50, and also we have after 2 years 20% has decayed. So after 2 years 20% has decayed, it means 80% is remaining. So remaining number of milligram is going to be 50 times 80%, that's going to be 0.8, and if you multiply you will get 40. So this is our p of 2 and p of 0. P of 0 is p0, and in our decay equation this is our decay equation. P of t is equal to p0 e power kt. Now in order to express in this equation we have to know what is our k value. To find the k value, what we are going to do is we are going to use this information, the p of 2 information, to figure out what is our k values. Now let's go ahead and plug the values in this equation, and we know that p of 2 is 40. So this is 40 is equal to 50, that's p0 e power k, and this is happening in 2 years, so this time is 2. Now let's simplify this one, and if you rearrange this one, this is going to be 40 divided by 50, that's equal to 4 over 5, that's going to be 0.8, and that's going to be equal to e power 2k. Now to get rid of this e, we can take ln both sides. So if you take ln, this is going to become ln of 0.8. In the other side we are going to have ln of e power 2k, and we can move this one to this side, okay, and ln and e multiply, and that's going to give us 1. So ln of e is 1, not multiply, ln of e is equal to 1. So ln of e is 1, and this is ln of 0.8, and therefore we know that ln of 0.8 is going to be equal to 2k. From this one we can figure out our k. K is going to be equal to ln of 0.8 divided by 2, and if you calculate that one you will get negative 0.1157. The negative, we have negative because when we have ln less than 1 we are going to get negative. So this is giving us negative 0.1157. Now we can go ahead and express in this equation pattern. So if you express like this, this is going to become, this is the answer for the first question, and you are going to have p of t is equal to p0. P0 in our case is 50. Now yeah, let's put 50, and e power k value we figured it out, that's negative 0.1157, negative 0.1157 times t. Now this is our equation. Also, if you want to express in this pattern, this is going to become dp by dt is equal to k times p. K is this value, negative 0.1157 times p. Now this is the solution for the first question. Now let's look at the second question. The second question is asking, b part is this is a, and this is b. How much is left after 5 years? Now we can use this equation to figure that one out. P of 5, that's what we are trying to find, is equal to 50 e power negative 0.1157 times 5, and if you calculate this one you will get approximately 28.6 milligram. So that's going to be the answer for the second question. Now let's look at the third question. Third question is asking what is the half-life of this material. Half-life is basically when how much time it will take for the half of this material to decay. Since we have 50, the half of it is going to be 25. So 25 is equal to 50 e power negative 0.1157 t. Now let's use a different color. Okay, so this is going to be, if I bring this 50 to this side, that's going to be half, and equal to e power, this is always going to be half because you are always, whatever the value you have here, you will always half here. So this will always be half, and this is going to be e power negative 0.1157 t. To get rid of this e, we can take ln both sides. So this is going to be ln of half is equal to ln of e power negative 0.1157 t, and we can move this one to this side, and ln of e is equal to 1. So this is going to be ln of half is equal to negative 0.1157 t. Okay, therefore t is going to be equal to ln of half divided by negative 0.1157 t, 557, because t is what we are trying to find. And since ln of half is less than 1, so this value is going to be negative. Negative, negative, you will get a positive value, and you will get 6.2 years. And that's going to be the half-life. And the shortcut method to find half-life is this. So whenever you're trying to find half-life, you can use this formula. T is going to be equal to ln of half divided by k. K value is the power we have, this value. Okay, this is our k value, and if you divide this one by that, ln of half by that, you will get half-life. And that's how we do this kind of problems. I hope this helps. Thanks for watching.